This is also another recent set question. The question is, which among the following quantities is not a vector? So most of you can easily find out the answer, and some of you maybe have some difficulty in identifying the correct answer. So just listen my lecture, and in this lecture I discuss little more about all of these quantities: moment of inertia, angular momentum, linear momentum, moment of force, and all. So when to solve another problem, this content will be very much helpful. Okay, so there are two ways you can see. One is moment of inertia, and moment of a force, and another word is momentum, angular momentum and linear momentum. So this word moment and momentum may be a little bit confusing, so I will discuss these are separate. So moment and momentum. Okay, so I am separating this content into two. Oh, my straight line is very bad. Okay, one more time I will try. Yeah, it's a little bit okay. Okay, so first we're discussing is moment of inertia. So moment of inertia is called as rotational mass or rotational inertia. Why it is called rotational mass or rotational inertia? The reason is here. Now we consider a translational kinetic energy. That is, translation kinetic energy is equal to half m v square, where m is the mass which is related to inertia, right? And what is rotational kinetic energy? That is equal to half I omega square. So this is velocity, v is velocity, omega is also velocity, there is angular velocity and linear velocity, and I must be mass, that is mass in rotational motion. So that is why it is called rotational mass. Okay, now we're taking an example of a ring. So a ring is the ring of certain radius, that is r, and this ring has a mass of m, and this is rotating about an axis. Let b is b z axis. Then this rotating ring has a tendency to continue its rotation. That is called its moment of inertia. So rotational moment. So what is this moment of inertia about this z axis? That is, moment of inertia about z axis of a ring Iz is equal to mr square. And if this ring is rotating about diagonal axis like this, about this axis, if it is rotating about this axis, then this moment of inertia will be equal to mr square by 2. This is for the case of ring. And in general, the expression for moment of inertia is I equal to summation I mi ri square. This is for discrete case. And another expression is I is equal to integral dm r perpendicular square. It is for continuous body. Now we discuss the another moment, that is moment of force. So what is moment of force? Moment of force is nothing but torque. Torque is rotating force. Suppose there is a rod, and it is here it is fixed in some it's an axis, it is fixed somewhere, and this body over this mass point, we are applying a force F, and this is a R vector. Then the rotating force acting on the axis will be tau is equal to R cross F. So moment of force, torque, is a vector quantity. Okay, force is a vector quantity and R is also a vector quantity. So this is a vector quantity. Now we discuss about different momentum. First one is linear momentum. So what is linear momentum? If there is a body of mass m, it is moving with certain velocity v, then it have a momentum p is equal to mv. Here v is a vector because it have both magnitude and direction. So p is also a vector quantity. And another momentum is angular momentum. So here, if suppose a string is there, it is a fixed point, and a string is there, and it is a body is attached to that string, and it is rotating like this. Okay, so at this position it have certain velocity, that is v. So there will be a linear momentum, that is p is equal to mv, and this distance from origin or center of the circle to mass point is r vector. Then angular momentum L is defined as L equal to R cross P. So here also the angular momentum is a vector quantity, and this angular momentum is called as moment of momentum. So the momentum is a general concept, that is if R is multiplied with any of this quantity, suppose R is multiplied with M, then it will be moment of inertia. And if R is multiplied with the force, then it will be moment of force. And if R is multiplied with the P, then it is moment of inertia.